Today's lesson is taking all that logic that we learned at the beginning of the year and applying it in triangles. We've been sprinkling it throughout. It was in angles. It was in parallel lines. But when we say logic, we're talking about hypothesis, conclusion, conditional, counterexample, proofs. So we're going to use all of those things and interweave it into our triangle unit and see what it looks like when we discuss triangles with our logic. Also, we're going to zoom in and focus on contrapositive. It's the last of our different logic sentences, and that's the one that you'll be tested over for this unit, okay? So, here's a quick review of the different conditional statements that we can write. There's the original. There's the conditional. If P, then Q. If it's Jersey Day at school, then I wear my husband's huge Astro jersey that looks like a dress. Okay, converse. If Q, then P. If I'm wearing this huge Astros jersey, then it must be Jersey Day at school. Inverse. If not P, then not Q. If it's not Jersey Day at school, I do not wear this huge jersey to school. And then contrapositive is where you take the converse and the inverse and you hybrid them. It's both of them. You switch places and you not. Yeah, you remember the cable guy and you get bored? Yep. So I don't even remember my sentence. If I do not wear the huge jersey to school, then it is not Jersey Day. Okay. Did you give a mouse a cookie? Yeah. So let's try some. Let's just focus on contrapositive. Let's write the contrapositive of different sentences. If a team scores the most points, then they win the game. What's the contrapositive of that? Everyone just say it in their head if you don't want to write it down. So, if a team does not win the game, then they did not score the most points. So you have to reverse your sentence and negate. Reverse and negate. Yes. So if a team does not win, they do not score the most points. Let's talk about the truth value of these before we move on to the next one. That sentence, if a team scores the most points, then they win the game. Is that true or false? So you can't think of a single counterexample. Exactly. What sport? People in my first period were saying, well, golf isn't a team game. But sometimes you can have a golf team and they add up the points and they throw out the highest one and they throw out the lowest one. No, soccer's not a good example because soccer, you do need to score the most points to win. So what is a sport where you want to have the lowest score to win? So to me, this would be false, and one of the counterexamples can be golf. Oh, diving? Do you want a low score for diving? So no, that one wouldn't work. Someone was telling me cross country. When a cross country team to score how many points they get when they have a meet, if you come in first, you get a point. If you come in second, you get 2 points. If you come in third, you get 3 points. So points are bad. You want the lowest amount of points to win the meet. So anyways, it's false, and one of the examples is golf or cross country. Okay, if a team does not win, then they did not score the most points. What about, so what is the truth value of the contrapositive? If a team does not win, then they do not score the most points. Isn't that the same argument? So it's also false, and I could use like the same exact counterexample. So it's like the original and the contrapositive have the same logic to them. Let's keep looking at that. Here's our next one. At Cy Falls, we have to wear IDs. Do any of y'all schools, do you have to wear IDs? So if we have an ID badge check in the morning and one of my students is not wearing their ID, I send them to the office. So in my class, for me being the teacher, this is true. If you do not wear your ID, then you go to the office. Okay, so what is the contrapositive of that? Yeah, so don't get tripped up by the not. We're not going to write, if you do not go to the office, then you do not wear your ID. The not canceled, and it becomes then you do wear your ID. So let's look at this. If you do not go to the office, then you do wear wear your ID. So a double negative, a not, turns into a do. Is that true or false? So it's in the morning, and I do an ID badge check, and a student does not go to the office. Don't you agree that they are sitting there wearing their ID? Okay, yeah, you're right, Alex. Some teachers don't follow the rules, so I am assuming, I'm saying in my class, when I do an ID badge check, let's do that. So if I do an ID badge check and a student does not go to the office, that means they are wearing their ID. The students that do not have to head to the office are the ones wearing their ID. Okay, let's do our last example. If a triangle is equilateral, then it is equiangular. Is that one true or false? Oh, Alex says they go to the library, not the office. I gotcha, I get you. That is very true, you're right. And let's write the contrapositive of that. Very easy. If it is not equiangular, then it is not equilateral. True or false? True. Very good. Now remember, that's only true for triangles. That doesn't work for quadrilaterals. Okay, so if you notice, this was false, false, and this is true, true, and this is true, true. So I'm kind of curious about that. And if you were curious about it too, then you can write this down in your notes. Believe it or not, a conditional and its corresponding contrapositive always, good job, they do always have the same truth value. A conditional and its contrapositive always have the same truth value. So if you're positive the conditional is true, and you're just not sure if the contrapositive is true or not, now you know that they have the same truth value. So if you're sure about one of them but not sure about the other, go with the one that you're sure about. Okay, let's take an old sentence from first 6 weeks, and let's write all 4 of them. Well, all 3 of them, because the first one's already written for you. If lines do not intersect, then they are parallel. Is that true or false? Very good. You guys remember, that is a false sentence, and our counter example is few lines. All right, let's do the converse. If lines are parallel, then they do not, I'm going to use this for intersect. There we go. If lines are parallel, then they do not intersect. True or false? Totally true. They're parallel, that's part of the definition. They're not allowed to intersect. Okay, inverse of the original one. Ooh, here's a not. If lines do intersect, then they are not parallel. True or false? If they intersect, here's the intersecting lines, those lines are no longer eligible to be parallel. True. All right, and last one. If lines are not parallel, then they do intersect. So if lines are not parallel, then they have to intersect. False again, right? In the same counterexample, it's few again. So look at that. False, true, true, false. So there's actually another conclusion we can come to. The original and the contrapositive have the same truth value, but also the converse and the inverse have the same truth value. So when you do your homework tonight, and you're having to write lots of sentences, converse, inverse, contrapositive, your truth value should always have a pattern, like true, false, false, true, or false, true, true, false, or true all the way down, or false all the way down. You get it? As long as the first and the last match and the middle two match, it should be like a sandwich. Okay. Alright, if points A, B, C, and D are coplanar, then they form a convex polygon. Draw a counterexample. So you would start off like this. You would put points A, B, C, D, whatever you want. You would connect them, and you're like, oh, well, that forms a convex polygon. So that makes my sentence true. So then you would need to adjust your picture to make sure that you found a counterexample if you really believed it was false. So I need to adjust my picture. I'm still only allowed to have 4 points, A, B, C, and D, but I needed to prove it wrong and draw a concave polygon, okay? All right, let's prove the exterior angle theorem, that theorem that we all think is so easy, but sometimes we forget to use it. Okay, so to prove the exterior angle theorem, we start with this statement. The measures of angle 1, 2, 3, the sum of those measures is 180. What is our reason? No. Thank you. Good job. The reason is called the triangle sum theorem. I think it's actually called the triangle angle sum theorem, but we'll just do that because of space. Okay. Now, we want to say that angle 3 and 4 are supplementary. Why are we allowed to say that 3 and 4 are supplementary? Good. Linear pair what? Is it the definition of linear pair or linear pair theorem? So you do have to be careful which one you're using, but it is the linear pair theorem. Okay, so now we said that they're supplementary. We've made that statement. Now, what do we want to say about their measures now that we know they're supplementary? They are supplementary. Good. So now that they're supplementary, we're allowed to say, oops, I got too excited at the plus there. The measure of angle 3 plus the measure of angle 4 equals 180 by the definition of supplementary. Now we can use some substitution. See how this one equals 180 and this one equals 180? Well, we can just substitute that in and say this one equals this one. That's what they said right here, substitution. And now what were we trying to prove in the first place? We were trying to prove the exterior angle theorem. So we better end up on the exterior angle theorem. So if we do a little bit of subtraction, if I subtract angle 3 from both sides, I have the exterior angle theorem. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Ta-da! Okay, let's do one more proof and then you're off the hook. Given the measure of angle 1 is 115 degrees, the measure of angle 3 is 60 degrees, prove that the measure of angle 4 is 125. So mathematically, you could find that very quickly, but we are going to write all of our steps down and back it up with theorems and definitions. Statement. The measure of angle 1 is 115. What's the reason? Given. Cool. Statement. Angle 1 and 2 are supplementary. What's the reason we used it in the last one? Yes. Linear pair theorem. Oh, we know this drill. Now what do we do by definition of supplementary? Yeah, okay. And now they did a couple for us. They said the measure of angle 2 is 65. They they did substitution and subtraction. They subtracted 115 from 180, but they had to substitute in 65 there. The measure of angle 3 is 60. Why is the measure of angle 3 60? Why? Given. Forgiven? Given. Ooh, now we want to say something, and we want to use the exterior angle theorem. What should we say? The measure of angle 2 plus the measure of angle 3 equals the measure of angle 4. And then if we substitute in everything that we know, Angle 2, let's sub in 65. Angle 3, let's sub in 60. So by substitution, the measure of angle 4 is 125. All right. You're done. Have a great day. Do your homework.